Good morning, students. So let us now we will take that is the one two example. Then we will discuss about the question. Is it visible? Hello, is it visible or not? Okay, thank you. Question number 6.66, 66 number of the chapter 6. A smoothly contoured nozzle with outlet diameter small d equal to the 20 mm is coupled to straight pipe by means of flanges. Water flow in the pipe of diameter capital D equal to 50 mm and the nozzle discharges to the atmosphere for a steady flow and neglecting the effects of viscosity. Find the volume flow rate in the pipe corresponding to a calculated axial force of 45.5 Newton needed to keep the nozzle attached to the pipe. That is the given. Axial force how much is required, so it should be attached to the pipe. You have to find out the discharge rate. Question number 6.66. Axial force is given. Draw a nozzle, that is the 45.5 Newton force is required. Pipe diameter is mentioned 50 mm. Nozzle diameter is also mentioned 20 mm. Yes, tell me the discharge. First, you should find out that is the velocity. Apply that is the continuity equations, Bernoulli equations, momentum equations. Yes, anybody solve, then tell me. So one dimensional continuity equation you may take that is that will come out the relation between the velocity area at the two sections 1 and 2, then apply that is the Bernoulli equations exiting and the atmospheric, and then momentum equations. Yes, anybody solve? Can I show that is a solution? Or you are trying? Tell me.
Sure, sir.
Is it visible?
Yes, sir.
So see here that is the pipe inlet side connected to the our nozzle at the section 1 and nozzle section is the two diameters both are the given. And this is the our sum that is the continuity equations from that is the V1A1 equal to the V2A2. This is the from the continuity equations. Then Bernoulli equations P1 by rho plus V1 square by 2 equal to the P2 square by 2. So here at the same that is the Z level, say no that is the potential head at that is the in and exit from the nozzle in the atmospheric that is also zero. So at section inlet is pressure and velocity, exit is only velocity. From these two equations that is the our continuity equations, Bernoulli equations, we can correlate these things. Then momentum equations. So momentum equations reaction is equal to the rho v1 a1 mv v that is the mass into velocity, change in the velocity v2 minus v1 mass that is the rate of mass, so density into the area at section 1 into the velocity at section 1. So this is the mass entering. So this is into the velocity change. Rho V1 A1 equal to the V2 A1. Or you may write from the control volume equations here that is the integral methods used in the continuity equations and that is the momentum equations. Or directly we can apply the continuity equation for one dimension and momentum equations. Both methods you can see and then you should get it the momentum reaction that is the rho v1 a1 equal to the v2 minus v1, and all that is the somewhere here given that is the then reaction that will transform from the pressure Bernoulli equations P1 equal to the rho V1 square by 2 into d a small d by capital D to the power 4 minus 1 here. So this so pressure, so that is the acting the pressure force left side equal to the right side mass into velocity. Pressure is reaction plus that is the your change in force, that is the due to the pressure force. So P1A1 minus P2A2, P2 is 0, so that's why it is adding only reaction force plus P1A1 equal to the rho V1A1 into V2 minus V1. Left side is the summation of forces, right side is the mass into the velocity, that is the momentum. And mass is change in the form of the density, that is the fluid property. So after the substituting from continuity equations, Bernoulli equations, you should get it Rx plus A1 rho B1 square by 2 dy d4 minus 1 equal to the rho V1 square A d by d2 ka. So that is the A1 capital D by small d ka whole square minus 1. From here we can find out V1. So V1 equal to the, that will here mention Rx. So after the calculation you must check it that is the correct or not, that will come out that is the 1.3 meter per second velocity, then discharge equal to the V1 A1. So all of you written. In this way, you may solve some problem related to the momentum, but Bernoulli equations, Euler equations, that is our continuity equations, you focus more. Is it correct? And I have sent that is the home assignment number 3. All of you got it or not? होम असाइनमेंट 3 मिल गया आप लोगों को कि नहीं?
मिल गया सर.
Okay, after examination you must submit 2 and 3, but for the practice I have sent you. You see the type of the problems and which I have also discussed and prepare for the end, the mid semester. I am going to load the syllabus, then we will discuss about that is the our questions. Is it visible?
Yes sir.
See, this is your course structure. First, that is the properties of the fluid, hydrostatic law, pressure measurement means manometer, all these what we have discussed in the kinematics, Lagrangian, Eulerian approach, velocity, acceleration, streamline, stream tube, continuity, motion, velocity, potential, stream function. Then that is the fluid dynamics here, Venturi meter, orifice meter, impulse momentum equation, moment of momentum equation, free and force vortex. So free and force vortex, perhaps I have covered or not covered the problem, I have not remember. But you must also practice for the free and force vortex flow examples. Theory we have discussed all the theory, which So up to here I have covered flow through the pipe, duct I have not covered, measurement orifice meter, notches were not covered, that is the dimensional. So see, up to here we have covered. So this is the syllabus about the mid-term. I hope that is the 5 question will be come from all these, that is the chapters. So, or if 3 questions, then A and B may be asked. Otherwise, 5 questions may be asked. So, one thing always remember, question comes from the properties of the fluid and pressure measuring devices. Second one here, that is the stream function, potential. All these are a big, that is the chapter having details. Second one, Bernoulli equations, Venturi meter, orifice meter. So one question is generalized, another one from the measuring devices. Measuring devices, pitot tube, Venturi meter, orifice meter, which also I have discussed in the class. Am I right? So you must be concentrate, and I have not covered much examples, but still the standard examples we have covered. So in the fluid dynamics, one from the measuring devices, one from the generalized question. Is it correct? One question there from the potential stream, another question is generalized question. So velocity acceleration in this chapter also we have discussed. So it is a note that is the only parts why question will be asked. Maybe sometimes mixed type of the question may be asked. Is it correct? So this is the all about that is our course structure before the mid same. If you have any query, then ask me. Otherwise, we will go just one, two more examples. Is it okay? Yes, tell me, is it okay now?
Yes, sir.
So as I think this is the our syllabus, but measuring devices you must concentrate. Am I right? You must concentrate on the measuring devices that will help you. Just wait one more. That is so. Let us see. Always you must focus on the numerical part. So are you preparing to join the NIT Jamshedpur?
Yes, sir.
टिकट आप लोग करा लिए हैं?
टिकट नहीं मिल रहा है अभी.
अरे कब करा लेंगे आप लोग को फिर टिकट से? वो पास वाले
तेल
रांची
डला
वाले,
लिए।
रांची बोकारो वाले हैं क्या? अरे बोकारो का तो बहुत लड़का रहता है, वो तो लोग एक गाड़ी रिजर्व करके आ जाओ सब लोग।
सर बिहार से है.
हैं कहाँ से?
बिहार.
यार तो पटना से चलेगा ना गाड़ी?
यस सर.
दिस इज द वेरी इंटरेस्टिंग कि आप लोग you have not seen that is the classes, you might be not the meet the teachers. आप लोग टीचर से मिले हैं कभी? एक दो टीचर से मिले होंगे।
नहीं सर, आप कहाँ से सर?
अरे हम तो देखो यही है न, हमारी भाषा से अभी तक आप लोग नहीं पकड़ा कि किस तरह का सर का टोन है, तब क्या तुम पूछेगा बताओ?
सर पकड़ लिए
बिहार
सर।
से
सर आप रहते कहाँ हैं? नेटिव कहाँ है सर? बिहार में कहाँ से?
अरे ठीक है, यहाँ आएगा मिलेगा तो सब पता चल जाएगा। आप लोग भाषा से नहीं पकड़ता है कि भोजपुरी है कि मगही है कि जनरल हिंदी है, क्या आप लोग बिहार का रहता है, हमें समझ में ना आता है। यूपी का है, किसकी कैसी भाषा है समझ में नहीं। लेट अस सी। देखिए वन मोर एग्जांपल। सो वी आर वेरी इंटरेस्टिंग कि आप लोग कम से कम इंस्टीट्यूट आएंगे तो हम लोग को इंस्टीट्यूट की जो स्टेटस कुछ लगेगा। अभी हम लोग जो है पूरी बंजर में रहते हैं। स्टूडेंट के बिना इंस्टीट्यूट का कोई इंपॉर्टेंस नहीं। ऑलवेज रिमेंबर, इंस्टीट्यूट इज ओनली फॉर द आवर स्टूडेंट्स, नेशंस स्टूडेंट। और देन टीचर्स रोल एंड रेस्ट आर द कस्टोडियन of the students and teachers records. That's all. This is the meaning of the institute or college और स्कूल। तो आप लोग को बिना स्कूल इस इंस्टीट्यूट की कोई जो है वैल्यूएशन नहीं है। आप लोग आएंगे घूमे फिरेंगे, जो लाइफ एंजॉयमेंट ऑफ द टेक्नोक्रेट ओनली इन द इंस्टीट्यूट। हाउस में आप लोग बंधे रहते हैं बच्चे की तरह, स्कूल की तरह। एम आई राइट और नॉट?
Right, sir.
Yes, sir.
So
Right, sir.
this is the golden period for the any technocrat. Hostel is another that is the a like that is the enjoying place and reading and working and interacting one another. This is that's why technocrat are the smarter than the other students. So let us see. We will take just that is the one more example, not and then we will leave it, and you should prepare yourself. Is it visible? बोलिए, दिख रहा है कि नहीं क्वेश्चन? हेलो, इज इट विजिबल और not?
Yes, sir.
Yes, sir.
Yes, see, 6 point question number 6.73. 6.73. A water jet is directed upward from a well-designed nozzle of area A1 equal to 600 millimeter square. The exit jet speed is V1 equal to the 6.3 meter per second. The flow is steady and the liquid stream does not break up. Point 2 is located H equal to 1.55 meter above the nozzle exit plane. Determine the velocity in the undisturbed, that is the jet at point 2. Calculate the pressure that would be sensed by a stagnation tube located there. Evaluate the force that would be exerted on a flat plate placed normal to the stream at point 2. Such type of the question you may face in the sixth semester in the fluid masonry, but here just due to the momentum, impulse momentum, that's why we are discussing such type of the problem. Six point 7.3, try please. So in the main period you try that is, then I will show the solution. In main period I will call your attendance, just please wait. Today is the last attendance before the midterm, just I will collect. Attention please, response your roll call. Roll number 1,
Present, sir.
roll number 2,
Present,
3,
sir.
okay, 3,
Present, sir.
4,
Present, sir.
5,
Present, sir.
6,
Present, sir.
7,
Present,
8,
sir.
7, 8,
Sir, 7 present है.
Present, sir.
okay, okay, 9, roll
Present,
number
sir.
9.
9.
अरे बहुत कम क्लास किया है 9, क्लासेस बहुत कम
वो
कर रहा है, क्या प्रॉब्लम है?
उस वो सर तबीयत ठीक नहीं थी मेरी।
सर वो गांव में रहता है, नेट उसका नहीं चलता सर.
अरे भैया तो एग्जाम में तो लिखिए देता है, तुम लोग देखते हैं किसी का नंबर फेल वाला पास वाला नहीं रहता है, सबका अच्छा नंबर रहता है. कहीं रहोगे लर्न सब तो इंड से यहीं आके दोगे. रोल नंबर 10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14, 15,
Present, sir.
16, 17,
Present, sir. 17.
okay, 18,
Present, sir.
19, 20,
Present, sir.
21, 22,
Present, sir.
22 अभी बहुत कम क्लास किया है 10. 23,
23 present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28, 29, 30,
Present.
29,
29 present.
okay,
Yes, sir.
30, roll number 30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36. So see, you must that is also try to solve the examples which I have given. So it is a striking above, that is the 5, that is the 1.55 meters. Is it correct? So you have to apply the Bernoulli equations. Roll number 37,
Present, sir.
38, 39,
Present, sir.
40,
Present, sir.
41,
41 present, sir.
42,
Present, sir.
43,
Present, sir.
44.
Present, sir.
अरे तुम क्लास नहीं किया 44, क्या नाम है तुम्हारा? एक भी क्लास उलास बहुत कम किया है, क्या बात है? क्लास नोट रखा है ना सब, जो लड़के लोग कलेक्ट किया है स्क्रीनशॉट में? हेलो, रोल नंबर
Yes, sir.
हाँ, बुक है कि
Yes,
नहीं
sir.
तुम्हारा? बुक है कि नहीं?
Yes, sir.
हाँ, सॉफ्ट कॉपी, हाँ थोड़ा पढ़ा करो, बहुत कम क्लास किया. 45,
Present, sir.
46, 47, 48,
Present, sir.
49, 50, 51,
Present, sir.
52, 53, 54,
Present, sir.
55, 56,
Present, sir.
57.
55 present.
Okay,
Present, sir. 59 present, sir.
okay. 57,
Present, sir.
58, 59,
59 present, sir.
60,
60 present, sir.
59 present.
61,
61 present, sir. Nitish.
62, 63,
Present, sir.
64, 65,
Present, sir.
66,
Present, sir. 66.
67, 68,
Present, sir.
69,
69 present, sir.
70,
70 present, sir.
71, 72.
Present, sir.
So see here, I am going to load the solution, and in this mean period, those who have completed, please check it. Then we will discuss it. Is it visible? Is it visible or not visible?
Yes, sir. Visible.
Yes, yes.
Visible, sir.
Okay, thank you. Roll number 73,
Yes, sir.
74, 75, 76,
76 present, sir.
77,
Present, sir.
78,
Present, sir.
79,
Present, sir.
80,
Yes, sir.
81, 82,
Present, sir.
83. So see here, that is the given how it is, that is injecting, that is the 1.55 meter. $84,
Present, sir.
$85,
Present, sir.
$86,
Present, sir.
$87,
Present, sir.
$88, $89,
Yes, sir.
$90, $91,
Present, sir.
$92, $93,
Present, sir.
$94, $95,
Present, sir.
96,
present.
okay, 96, 97,
Present, sir. 97.
okay, 98,
Present, sir.
99,
Present, sir. 99.
okay, 100,
Present, sir.
101, 102, 103,
Present, sir. 103.
okay, 104,
Yes, sir. 104.
105, 106,
Yes, sir.
107,
Present, sir.
108,
Present, sir. 108.
okay, 109,
Present, sir.
110, 111,
111 present, sir.
okay, 112, 113,
Present, sir.
114,
Again, sir.
115,
Present, sir.
116,
Present, sir.
117,
Present, sir.
118,
Present, sir.
119,
Present, sir.
120,
Present, sir.
121,
Present, sir.
122.
Present, sir.
Sir, roll number 14 छोड़ दिया sir.
Sir, roll number 19,
Present,
sir.
अच्छा जस्ट हेलो आप लोग ज्वाइन नहीं करता है इसलिए छूट जाता है जस्ट वेट सो से दैट इज आवर सो लेट अस सी so a water jet is directed upward here see water jet that is the in bottom and it is a upward directed area A1C 100 millimeter square and the exit jet speed V1 that is the given 6.3 meter per second. The flow is steady and does not break, mean continuous. 0.2 is mean that is the one here jet exiting and somewhere that is the 2 it is the from exit 1.55 meter above it is the given. Nozzle determine the velocity in the undisturbed jet at तो जेट 2 निकला वहां calculate the pressure that would be sensed by a stagnation tube located there. If we will locate that point, evaluate the force that would be exerted on the flat plate, place normal to the stream at point 2. तब कितना लगेगा? That's all. So this is the our question. So see, here the Bernoulli equation. So exiting, that is the 1, and where it is the 0.2, 1.55 mm is marked here. Bernoulli equation is written. From these relations, we can find out the V2, and that will come out 3.05 meter per second. And pressure at that is the what, that is the here given at O. So P2 plus 1 by 2 V square by 2, that is the P atmospheric plus half V square. And then this is the given, apply then momentum equations on, that is the our here striking the plate, when we should keep at the 2 striking the plate. So reaction summation of forces equal to the mass into the velocity. Mass is written rho v1 a1. This is into the velocity, and that will here reaction that will come out, that is the 11.5. And these are the distribution of the pressure here, that is the written. Am I right? See, in this way, that is the practice, and Fox and McDonough, Frank White, or you might be also collected some other book, one big book, that is the, or after joining the institute, you may collect from the library. There are so many books are available in our library, and it is in idle situation from last 2 years, so you may come and collect the book from the library and try to study for the in semester, and we will cooperate and take the classes also. So we will complete the attendance part, and then we should go to the next. Yes, tell me that roll number.
Sir,
Sir,
14.
19.
Sir, just wait, please. First 1 to 36. 19, okay, then roll number
14.
14.
16.
16. Yes, roll number 21. Roll number 28. Roll number 36. Next, roll number 38. Roll number 46. Roll number 47. Roll number 49, 50. These roll numbers are existing or not existing? Okay, you might, I don't know about physically not interacted. Roll number, that is the 52, 58, 62, 64, 67, 71. Roll number, that is the 74, 75.
Sir, 75 present.
Okay. 83, 88, 90, 92, 94,
Yes, sir, 94.
96, 101, 102, 105, 110. Anybody left? So see,
92.
92, just hurry. 22. So see, in the midterm, you should write down very carefully. Don't copy, and always you should apply your common sense. Someone written wrong, you should not copy it, and you can write only correct thing. Some symbol may be used, you are not getting, then you can apply your common sense, then you should write down. Otherwise, you should writing velocity, volume. These are the very confusing. And whatever I have given the home assignment and we have solved, if you are able to practice these things, such type of the question may be able to solve. If you have any query, then ask me. You have any query regarding the mid-sem?
No, sir.
See, the question will always ask numerically, not theoretically. You have to solve the problem, not that is the only theory, because this is the open book system. So as I hope you might be able to solve these problems and then prepare to join the institute. Any other query? So today we will close now.
Yes, sir.
So okay, thank you and best wishes for your examination.
Thank
Thank
you,
you.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank
Thank you, sir.
Thank you, sir.